rules. So no matter what kind of algebra you do, I mean that's the rules we use, which we should know. Just like when you play any sports, you got to know the rule. So, and the rule actually have three sets. We got the first set is properties of operators. Properties of operators. We know in algebra, really we come on to it just two, addition and multiplication. And the reason for that is in algebra, we're dealing with real numbers. So therefore, subtraction can be written as addition, just adding is opposite. And division is, we can convert that into multiplication, multiplying the reciprocal. So that's why we only concern those two operators. And exponent is basically just multiplication multiple times. So then the second set is the properties of equality. Equalities. And third set is properties of inequality. Qualities. So that's it. No matter what can you do, which is basically the rule are the same. And we also make that important to know the rule. Once you're familiar with the rule, then algebra problem is will be pretty easy for you. Okay, so let's look at the first set. First set, we actually got this. Add multiplication, we got a plus b equals to b plus a. And a times b equals to b times a. So you can see that this is different from order operation. And this one basically saying the order, it doesn't matter if you add or if you multiply. Yeah, you can order it. The number can be swapped, basically. This is called commutative. And we also have a plus b. Yeah, this is about order operation. A plus b plus c, that's the same as a plus b plus c. And or if you multiply, you can do whatever, any two first. It really doesn't matter. Yeah. So the reason for that is algebra is higher level math than arithmetics. Order operation are the rules. Is a rule for the arithmetic. Since we got a higher level, we got more freedom. So we don't have to follow that order operation. Okay, but you have to know when to do that. Okay. Okay, then we got a. This is called associative property. Then we got a plus its opposite equal to 0. And a times its reciprocal is 1. And so that is our inverse. And we have a plus 0 is a, then a times 1 is a, so that's the identity. And then we have this famous distributive property. So that get distributed. And you can see we use that a lot in algebra because algebra we're dealing with variables. So a lot of times we have to separate them out by using the distributive property. A plus b and c. Yeah, when you actually doing arithmetics, because arithmetics always just dealing with numbers, so you basically just add them and times c. But again, so sometimes we have to separate those two numbers. So that's why the property become important. Okay, are we good here so far? Yeah, if you're good, just give me a thumbs up. Okay, thank you, Abby. All right. Now looking at this the second set, which is the properties of equality. And there is something is so obvious. Normally we don't pay much attention to it, but it's still the rule. So basically it said a number equal to self, there is reflexive. And we also have A, if A equal to B and B equal to C, then A is equal to C. And this is called transitive. Now we got then we have if A is equal to B, then A plus C equals to B plus C. And this is called additive property, or sometimes just called addition property of equality. We can both say the same thing. And if A equal to B, then A times C equal to B times C. So this is a multiplication or multiple multiplication property. Multiple multiplication property. Okay, so that's what we are doing. When we solving problems, we use those. And when you're looking at how we solve linear equations, quadratic equations, we basically just use those rules. And there are other rules, but those are the three fundamental sets of rules. So today we're going to look into inequality. Then that's our third set. Third set inequality is we got if A is greater than B and B is greater than C, then A is greater than C. And similarly, if A is less than B and B is less than C, then A is less than C. So that's the called transitive property. And then we got into if A is greater than B, then A plus C is greater than B plus C. And that also works for the other way around. If A is less than B, then A plus C is less than B plus C. And then we have this multiplication thing. If A is greater than B, then A times C is greater than B times C. But we have a condition. C has to be positive. Now, if C is negative, then we had to flip it. Then C is negative. Good? Yeah. Okay. Then this also works for A is less than B. So we have that. Then A times C is less than B times C as long as C is positive. Or A times C has to be greater than B times C if C is negative. We have to flip the inequality. Okay, so today we're going to be looking at linear equality and systems of linear equality. And so linear equality is when we have y is greater than, say, something like, say, 3x plus 2. Now, to graph this, what we need to do, we're going to graph the line y equal to 3x plus 2. And so the line we got is, we know y-intercept is 2. And then we go use the slope. That means if our run is 1, then our height will be 3. 1, 2, 3 will be here. So that's the line here. And we use dashed line because it's not included. This is just greater than. If it's have equal sign, then we have to use solid line. And now, whatever satisfies inequality is the solution. So you can see that when we're dealing inequalities, the solutions are many, and in this case, infinite number of solutions. But for linear equation, if you want to solve linear here, for this one, the solution for the linear equation is also infinite, but just point on the line. And if you find this point here, this one does not equal to 3x plus 2 because it's not on the line. But for y is greater than, it's just any y that is above the line. So the solution will be those.
Could you go over that again and show me how you got your 2 points?
Well, first of all, do you know how to get the y-intercept?
I'm assuming we've already gone over this, and I do at some point, but I don't remember.
Well, y-intercept is, if we want to draw this line, now, for a line, we just need 2 points, right?
Yep.
So the y-intercept is super easy because that's when x equal to 0. When x equals 0, y has to be equal to 2, right?
Yep.
So that's our y-intercept. Once we find it, that's first point. Then we just find the second point by using the slope here. Good.
Yep.
Slope is 3, which means 3 over 1. We know the slope is rise over run. And so our run is 1, so that's why I go 1 to here. And the rise is 3, so we go 1, 2, 3. That's give us our second point. Good.
Yep.
Once we have second point, we just can draw the line. But because we're trying to find a solution for this inequality, so the line has to be dashed. That means we do not include this line. Good.
Yep.
Okay, anything above that, so basically any y above this will be our solution. Okay, now let's look at another example. So this time it's less than, let's say it's negative half x plus 2. Well, this one does include this line. So this line will be a solid line. And again, our y-intercept is 2, so we find it 1, 2. And from that point on, the slope is negative half, which is negative 1 over 2. And so our run will be 2, 1, 2 here. Our rise is going down by 1 because it's negative, so going down to here. And then we draw this line here. And that's what we got. Oh, sorry, other way around because it's the last thing. So that's our solution here. Good.
Can you explain to me how you got or how you did half again? Because I know it's rise over run, and
Right.
so half would be your rise.
What the rise will be 2. The run, sorry, the run will be 2. Rise will be negative 1. Okay.
Oh, okay. It's not half.
No, well, it's half.
Oh,
But in terms of rise or run, then the rise is negative 1. The run is 2. Good.
yep.
So that's why we run is by 2. And because it's negative 1, so we're going down by 1 instead of going up. Good.
Yep.
Okay. So I have you try a couple and you just do it. Work on that, then I'll show you the answer. And you can check whether or not you got right. Y is greater than equal to, so 2/3 x minus 1, and see what you got. Yeah, if you got down, just give me a thumbs up, okay?
We both gave thumbs up.
Okay, well, all right. So now first let's draw this line. Is 2/3 x minus 1. We got okay. Well, we know our y-intercept is -1. So rise over run. So the rise is 2, run is 3. So we go 1, 2, 3, then go out by 2. So that's second point. And that's included, so it's solid line. Okay. And anything above that will be the solution. Okay, if you got this right, just give me a thumbs up. Thank you, Addie.
Why did you go over 3 and not 2?
Well, because our run is 3. We got 2/3 here. The top, rise over on.
Oh, then I did it backwards.
Good?
Yep.
Okay, all right. I'll give you another one. Y is less than negative 3/5 x plus 3. Okay. All right. So we're going to looking at this y equals always draw the line here. So in that case, our x y intercept is here. And rise over run is negative. Negative, is going downward, so downhill. So our run is 5. So go 1, 2, 3, 4, 5, then going down by 3. 1, 2, and 3. So our line is going this way. And it's less than, so everything going down. Good. All right. Thank you, Matthew. Addie? Okay, now we're going to get into so-called systems of linear inequalities. That means we actually get two inequality, and we put something like this, means that the solution has to meet both inequalities. So if I say y is greater than, say, x plus 1, it's a very simple one, and y has to be less than or equal to negative x minus 2. So how do we do that? Well, we do two of those, and we're going to find the overlap, because this indicates that whatever is the solution to the, if it's a solution for the system equations, it has to satisfy this inequality and that one. Okay, so we draw the first one, which is here, and rise over run, go one by up, down here. And that's this one. And it's up, so therefore that's that. And another one is y less than or equal to negative x, negative 2. So we got 1, 2 here, and we go, this is wrong, and going down by 1. And that's solid. Okay, and we're looking for less than equal to. Well, we know anything less than that, like any point here, only satisfy this inequality, but not the top one. And so the solution has to meet both conditions. So it has to be greater than this line, dashed line, and also less than the solid line. So you can see that overlap actually is here. So that is a solution. That's the overlap between those. Good.
How did you figure out your rise over run for this? Because it's just an x.
Well, that's 1. The slope is 1 for top one. This one.
Okay, but then what would your run be?
Well, it's just 1 over 1. So rise is 1, wrong is 1.
Oh, okay.
Good. And for the
Yep.
second one is less than 1, so basically it's less minus 1 over 1. Good.
So it's -1 over -1, or just -1 over
1
1?
over 1, because -1 over -1 is just positive 1, right?
Yep.
So -1 means -1 divided by positive 1. Good.
Yep. So, but then why didn't you go up with the second one? Then why did you go down?
Well, because our rise is negative.
Oh, yep. I had it backwards again. Yep.
Okay. All right. I'll give you a couple to practice on. Mhm. Hmm? X minus 1 and y is greater than negative 3x plus 2. Okay. All right. Thank you, Matthew. Eddie,
Yeah,
you done?
yeah.
Okay. Sorry, I didn't see the hands up. Okay, let's see. The first one, we got -1 here. Rise over run. Our run is 1, rise is 2. So it'll be here. And that includes that. And it's less than, so everything down here. And for next one, we got negative, the y-intercept is 2, and it's -3, which is -3 over 1. So go there by 1, go down by 3. 1, 2, 3 will be here. And that's this line here. Okay, and it's greater than, so it should be top here. And we see that our overlap actually will be this part. Okay. Yeah, if you're good, just give me a thumbs up. Okay, thank you, Eddie.
I'm kind of confused on the first one. So I got the -1 down, but then I went the opposite way with the rise over run. I went 1 the other way, and then
Yeah,
what was it?
you always go to the right. Good.
You always do no matter what?
Yep. So always go to right, then decide is positive, negative, going up or going down. Good?
Okay, and then it was positive, so you went up too.
Right. Well,
Oh,
Yep. Mhm.
okay.
Good.
Yep.
Okay. All right, let's try one more. Okay. Thank you, Eddie. All right, so let's see what we got for this one. Okay, for this one, we got one here. Now, our rung is 3, 1, 2, 3, and going down by 2. So that's right, it's negative. Then we got this line here. And it's less than, so it has to be anything here. Then we got this line also being cruise line. So come at -1, -2. And our rung is 4. 1, 2, 3, 4. Then rise is 3, go back by 3. 1, 2, and 3. Over here. So the line is going like that. And anything is below that. So that means our overlap will be this part. That's our overlap. Okay. Yeah, are we good on this one? Thank you, Matthew. Yeah, Eddie, we good? All right. So that's what we have for today, okay? And I didn't get chance to send out the homework for last week. I'll send it out both, okay? Yeah, to send out last week homework and this week's homework today, okay?
Okay.
All right.
Okay, yeah, that had me confused because I know I missed 2, so I did 10 and 11,
Right.
but apparently I've already done 10. So,
Okay. All right.
okay, thank you very much.
Well, you're welcome. Bye.
Bye. Thank you.